Can you guys hear me okay? All right, cool. So my name's Pramod, Mode for short. I'm the CEO and co-founder of a company called Airagility based here in the Washington, D.C. area. Specifically, we're in College Park. And obviously, we've had a nice range of speakers today. Good selection by the committee so far, I think. And I'm going to totally do something different than they did. So hopefully you guys will get some fun and some learning out of this. So what I'm going to talk to you today about, we're here for data analytics exploration. I think what I'm going to talk to you about is more about the exploration side. There's a lot of data and a lot of analytics involved with some of the things I'll describe to you, but I'm not going to go in depth with those. So title of my talk is Trust in UAS AI Autonomy. So UAS stands for uncrewed aircraft systems or aviation systems, however you want to say it. And most of you know those kind of things as drones, as what the terminology you'd probably use. So these days, as we get into the world of drones and aeronautics and all that stuff, it's a whole new world. And drones have been around for a while, don't get me wrong, but they weren't doing a whole lot for a long time, and now they are starting to do a lot. So that's what I'm going to talk to you guys about today. In terms of what I'm going to do today, I'm going to kind of take you on a little journey of bridging the gap between manned aviation and then unmanned, and then how that plays a role in all the different applications, use cases, and get into a little bit about what we do at our company, just to give you a kind of a teaser of what's out there, because there's a lot out there. And I know the audience here is fairly mixed. We got students, we've got career changers, we've got a whole bunch of different people. So you guys will learn a little bit today, hopefully, about what opportunities are out there as well. As I mentioned, as he mentioned, I have 25 years kind of been doing entrepreneurial stuff, serial entrepreneur. I don't know if that's a good thing or a bad thing, but it's something I love. So I'm also an aerospace engineer. I have lots of flying hours, many different types of aircraft, lots of experience with human factors, which plays a role when it comes to AI, because as we talk about AI, we're going to talk a little bit about what is automation, what's an autonomous system, and human factors plays a big role in that. And so a little bit about Airagility. Like I said, we're based in College Park. We're just about 5 years old. First few years, heavy R&D, really doing like small R&D contracts with the government. Now we're actually at the product stage. So it's been a bit of journey, but we're doing some of the hardest things in the world. So can't complain too much either. So this is a cockpit of an old airplane. Like, think of a biplane from way back in like the 1920s or 30s. And this is what you had in if you were the pilot, this is what you saw, this is what you looked at. And these were the only gauges you had, essentially. So not a lot. So it tells you the basic things of how high you are, how fast you're going, how much fuel you have, things like that, right? Fast forward to the flight deck of today, which this picture is actually probably of technology that's 30 years old. But it's still being used today. Still very, very advanced. But there's a lot of automation and a lot more that you can do by just pressing a button and actually have it done. But you still have to fly it. So if we now transition to the world of uncrewed, we used to call it unmanned, we call it uncrewed now, of drones. Here's a guy flying a drone. And so we have people out there that are qualified drone pilots. They have to go get their license, they have to go get training, and they learn how to fly drones. And that's not a bad thing. However, if you watch the news today, or who has drones? Anybody have drones here? No? Okay. They're more autonomous. So you could go to maybe Best Buy or online or something. You could buy a drone that actually does things by itself and acts a certain way if you ask it to. So they're more automated, somewhat autonomous. And I'll get into the definition of automation and autonomy here in a second too, but I want to just give you a couple of examples of what's happening right now. The picture you see here, that's essentially like a consumer drone. You could buy that right now and go into the woods and run around, and to a certain extent, it'll follow you and take pictures if you want, things like that. So let's get into the definitions. So development of automation here is what I have on the slide. And I showed you a manual drone being flown manually, and then you hit a couple buttons that can do some tasks. And then we get into what we call autonomous. So what does autonomous mean? It means that system now can be self-ruling, that it can think on its own. So an autonomous system is going to be able to respond to dynamic conditions and even maybe think on its own and start making decisions, whereas just an automated system is going to have a specific task. That's what it does. Might have some rules around it. And that's what we do in manned aviation. In manned aviation, to this day, now you probably have seen some videos online, maybe. There are videos online of the first dogfight with a completely uncrewed fighter jet fighting a manned fighter jet, and the results of that. And it's pretty impressive what the AI can do there. But traditionally, and this all applies to the uncrewed world as well, that as you're flying something, even if it's a drone, you've got to ask yourself, what's it doing? Why is it doing that? What's it going to do next? And so in the world of crewed aviation, these are things that you have to do. And so you treat the autopilot as a team player. It's just another tool you have. But whether you trust it or not is a whole different story. And so the interface that you use drives that trust. And then the outcome that comes out of that automation drives you to trust it or not trust it. And I can tell you many stories of autopilots that didn't do what was intended. So you're wondering what the heck happened, right? And so hence why you're in the human in the loop. So the same thing's happening right now with drones. Drones crash, they get into situations, and you're wondering what the heck happened. If I go back here to manned or crewed aviation, we can see there's many accidents that have happened because of the misunderstanding of how the automation was supposed to be used. This is Asiana 214 a few years ago. It crashed in San Francisco, just short of the runway. And in that case specifically, the pilots became over-reliant on their automation, weren't paying attention to what was actually happening to the aircraft. And I shared the words UAS with you, which stands for uncrewed or unmanned aircraft system. Well, UAS also has another term, or another meaning. It means undesired aircraft state. So in that case, they had an undesired aircraft state, which is it's getting low on speed, it stalled, and they couldn't kind of run the throttles fast enough to get it out of there, and they crashed just short of the runway. Really an accident that could have totally been avoided. And so there was an over-reliance, we'll call it, on the automation there, where they weren't really paying attention. There's a lot of viewpoints on artificial intelligence. This is one I like, and it's once you trust a self-driving car with your life, you pretty much trust artificial intelligence with anything. And I don't know if you agree or disagree with that. I sort of do, because I have a Tesla. And when I drive my Tesla and I put it on autopilot, it doesn't do everything it's intended to do, or it doesn't do it the exact way I want to. And we can see, if you, again, read the news or go to Google, you'll see examples of Teslas crashing or something happening where the user, the driver, thought, oh, I didn't think it was supposed to do that. And maybe they weren't paying attention again. So hence why we still have human in the loop quite a bit for a lot of all these things. So now if we go back to the drone world and what's happening right now, you have to look at the drone world as a system of systems. There's a whole bunch of things that are at work. You've got the platforms, you've got the data links, you've got sensors, you've got all these things in the system that have to work together. And if we come back to manned or crewed aviation, well, there's a lot of airplanes in the sky, right? There's a whole system of system there. But now you've got to have the unmanned or uncrewed aircraft working in concert in the same airspace or close enough airspace to crewed aviation. So what we don't want is that, right? You don't want that near your aircraft, because that could be catastrophic. And again, if you Google it right now, you'll see plenty of examples of this happening, where maybe nothing got hit, but it's close enough, close encounter. Not where you want to be. So then we combine those two worlds, and you get something like this, which now becomes a much more complicated system, where you're combining the national airspace system along with the system that's being developed for uncrewed, which is called unmanned traffic management, or UTM. And so now you have all these other things playing together. You've got to have, so if you now take this back to AI and autonomy, you've got to have collision avoidance. So these aircraft have to stay away from each other. They've got to have ID, so you know where something is at all times. right? So in manned and uncrewed aviation, we do have that, but drones, that's still a burgeoning thing that's happening. There's new laws that are coming out this fall that will mandate that everybody has remote ID, as they call it. So these are things that are happening. I went to a meeting when we started, shortly after starting the company, I think it was early 2018, and I was downtown at something, I think it was the Consumer Telecom Industry Association. Everybody was there. Amazon was there, Verizon was there, NASA was there, and NASA did a presentation, NASA Ames. This is actually a NASA Ames slide. And they said, hey, we're going to have drones flying all over the place, mixed into the airspace system by 2021. So this was almost 4 years ago. Well, here we are in 2022. We're not quite there yet. There's little pockets of areas where you can get waivers and fly around a little bit, but it's not ubiquitous yet. And it's still going to be a little ways away. But as you can imagine here, there's a lot of data at work. There's a lot of things at work that, as these little experiments and pilots kind of pop up, we're going to gather that data. They're going to take that and start to figure out how the system really should work. So if we go back to drones now and unmanned systems or uncrewed systems, there's lots of use cases. I'm not going to go into all the use cases today, but I'll give you a few examples. And some of them are consumer, many are B2B, many are focused on safety and ROI. And so why would you use a drone in a certain case? What's the business use case for that? Would it be maybe delivering pizzas? I don't know. I don't know if there's an ROI on that. I think there was a company here locally that was trying to do that. I'm not sure where they're at right now. But I think there's a lot more practical applications. But delivery is one, for sure. If we go back to COVID 2020, you probably saw this on the news. This is China, and they were using drones to spray. I don't know exactly what they were spraying, but they were spraying something, maybe to help stop COVID. I don't know. But they were using that. And then here's a great use case. This is a company called Zipline, and they have a catapult drone. Drones, by the way, come in all kinds of shapes and sizes and methods and ways of launching them, landing them, catching them in a net, et cetera. They're using a catapult here. The drone takes off. It's a little drone, and it drops blood, essentially, in a village where they need it, the local hospital or what have you. And so they're all over Africa right now, or in different parts of Africa. Is where they're mostly doing this. And then this is the Amazon drone, which has since been scrapped. I think they've waiting for all the regulatory stuff to happen to be able to deliver. They've kind of outsourced most of this now as well. And then what do we see in the future? I'm going to actually fast forward a couple slides and come back. Who knows who these guys are? Just say it. Yeah, the Jetsons. Yeah. So this is George Jetson. So if I come back a couple slides here now, hang on. One more. Nope, one more. There, I want to go there. So if we go back to that delivery, Amazon delivery, how are they going to do it? Are they going to land in your backyard? Are they going to land on your deck or your front door? I don't know. That seems like there's a lot of room for litigation there and legal things that could happen in this country. And so what we're probably going to see, and I'm just going to give you a glimpse, is some kind of station that's somewhere in your neighborhood. It drops in, drops the package as a QR code or some other way to drop the package into the right compartment, and then you show up and either do a biometric thing or a code, and you get your package, right? So there are companies working on that right now. How far into the future is that? I don't know, but it's being worked on. If you ask them, it would have already happened, but it hasn't. And then, of course, we have airports, but at some point, there are going to be these kind of aircraft flying around. Again, if you Google this, there's urban air mobility. There's a ton of companies working on this. Joby, Lilium, a few of those. Jaunt Aviation is one that we have partnered with. And you're going to see these kind of things that are designed as sort of urban taxis or vertical takeoff and landing taxis, so the Uber of the skies, so to speak. In fact, Uber was working on this for a little while as well. And then you come back, another slide here. Where will they go? Where will they land? So the idea is that we have these vertiports that are stood up in different parts. And there are a few cities in the world that are already building these. I think Dubai is one of them, actually. So it is becoming a reality. How fast we get there, I don't know. But again, so if we come back, if we leave all this fun stuff here and we get now to a more technical slide, this is something our CTO created that as we were trying to, as we were going out there and talking to companies and talking to people about where they might be able to use AI and autonomy, because that's what we do, there's different use cases. So we created this to sort of look at the complexity of the mission, whether safety was an issue, and then where does AI and autonomy play a role, and how much do you really need, how much do you really want? And depending on who you talk to, again, this is stuff that I'm not going to get into today, but something for you guys to think about is the ethics of AI. How much AI do you really use? And so the DoD, that's something they think about a lot. And you're going to see a panel a little later where they're going to talk about cyber, and they'll probably touch on some of this stuff as well with the future of AI in the DoD. And I'm not going to read all that to you, but these are the tenets from the DoD as far as ethics are involved. Some of our adversaries don't have these sort of ethics. So there's a whole debate around how much do you let it go, and how much do you have to keep that human in the loop to press that button or what have you. So just something to think about. So segueing a little bit into what we do, like I said, we're about 5 years old. We got our start working with the Department of Homeland Security. There was a contract out there we subbed on, which was, hey, we want to build more robust, autonomous vehicles that could be used in indoor environments. And why is that important? So DHS was looking at this from a smart cities perspective. How do we use technology, data, all that to improve life in cities? And so what they did is they assembled about 14 companies of all different walks of life, from cyber to other types of hardware, IoT type stuff. So if we just go back just a week to the unfortunate mass shooting, one company that was in our cohort, they actually make smart signs. So for example, if they actually have like an IoT device in there that can warn and communicate with first responders, for example. In our case, they wanted a robust UAS that could go in and look at search and rescue situations, look for signs of human life, for example, in a disaster situation, or purely surveillance or getting into the building before the first responders have to go in as well. So we were fortunate to be selected for this, and that's how we actually got the company rolling. We actually started to work on this technology with the goal of the program to be that you commercialize it, which is what we've done. Now, in the life of any young company, you don't always end where you start. You kind of pivot around a little bit and you figure out, well, what's going to work, who's going to buy, et cetera. And what we figured out, and this is what we solved, we figured out that there's this problem where you want to be able to actually do computations on the edge. So instead of getting your data and then pushing it to the cloud or to a USB and then downloading it and post-processing it later, meaning I have to now go and sift through hours of pictures or video, which in some cases works great and it's fine. But in other cases, you want that data right now. And so mission critical situations is what I'm talking about, whether it's public safety, whether it's DoD, or even in the commercial world. There are examples I could give you of utility companies or companies that are doing inspections of, say, transmission lines that have their whole team out there and they find something wrong. And they're like, hey, if the drone can tell us this right now, meaning on the edge, off the device, off the drone that's flying around, that's great because we have our team out here right now, we can fix this, as opposed to having to send them back out, which means more money and time, man hours for them to send them out. So these are some examples. So what we do is we do edge processing. We actually have our computational board on the drone. It's doing a lot of high-level algorithms and things like that, which I'll show you in a second, and delivering that to the end user via a tablet interface. We also make it very easy to fly, which I'll tell you about in a second. So what ends up happening is you end up with a whole bunch of buttons on your tablet interface. If you want these buttons, it's kind of configurable to what you want. And you have this decision making that's happening. The most basic things are like sense and avoid. Hey, I'm flying around, I'm the drone, I kind of shouldn't hit something, right? And that is a problem, by the way, with manually flying drones. They do hit things. And if I just come up a slide here, if you can read that, it's basically saying manual drones have failed to really give you an ROI because you still need operators, you still need people out there to operate these things. So the real focus now in the future is on self-flying, and that's what we do, is focus on the self-flying piece of it. In fact, we were just in Israel doing some demos for the Israeli Ministry of Defense and the Pentagon, just because this is something that's a big ticket item that they would like to solve, and they don't have a perfect solution for it yet. They're using bits and pieces, of course, and they have platforms they're using, but they're not entirely happy, and they want to see more improvement. So going back to this, yeah, there's just, if you can read that, there's a lot of different things that I'm not going to explain all that to you. We don't have time, but basically I could press a button and say, do this or do that is really the idea here. And then the drone and it's almost at a point where that earlier slide I showed you where you get to almost complete autonomy where you don't have to be even in the loop is very close. This is a picture of our office in College Park where we have a flying facility there where we're demoing, testing, integrating, all that sort of thing. And at the end of the day, and I'm telling you a little bit about air agility, but this is something that's happening across the industry where autonomy is being put into these professional applications from various companies for various use cases across enterprise, public safety, and DoD as well. So a lot happening. In our case, we have our own patented platforms. We do a lot of additive manufacturing. We 3D print these, and that's what that's how we've sort of done it. We've now started to take the software piece and put that into other drones as well. So we have a couple pilot projects going on with that. And essentially, like I said, we make it easy to operate. So anybody in this room could become a drone pilot with one of these drones in about 30 seconds. And then you layer in the AI. So AI becomes really important here because what our prospects, clients, everybody are telling us is, hey, we want to keep our data, right? So if I go buy an off-the-shelf commercial drone or commercial off-the-shelf drone, I can't keep my own data. And so we were able to put customized data sets on our drones, and then they can kind of put their data on and then learn as they go out on a mission, get that data, get more insights, and figure out what they want to do. And I'll give you a couple examples of that. And then, of course, the big one is here we're also able to fly in GPS-denied environments. We use a combination of vision, so cameras, and lasers. So lasers, there's different devices for that. We use a LiDAR as an example of that. And essentially, the sensor fusion of that along with the algorithms that play together, now allow you to have your own vision or your own situation awareness. You don't have to depend on a GPS signal. And this is a problem not just indoors, where you don't have GPS, but also in the shadow of buildings. If you're in an urban canyon, for example, where you're in we call it, a city, we call it an urban canyon, and you're flying around, how many of you have ever had your cell phone and you're walking around a city and you're looking at your little map and it's just kind of all confused, right? That's an example of maybe you've lost one of the satellite signals. So that happens. And you don't want that to happen with a drone because it'll crash, most likely. So as I mentioned, we use our own tablet interface. As we take off, we can map around us and essentially, the drone can figure out where to go. And it's point and click. Just press on the screen and it'll go. Why do we do this? Why does it matter? It's all about ROI. When we talk to public safety, DO, it doesn't matter who we talk to, they tell us that a large part of their budget is training. They've got to train people to learn how to operate these things. So if we can reduce that training time, that's huge. If we can avoid drones from crashing, that's huge. You don't lose the asset, which is potentially thousands and thousands of dollars, which happens. And then, of course, safety does boil down to money, too, but it has its own ROI in terms of human life. So in the DoD world, if we can keep some of our soldiers safe, put the machine in harm's way, I would prefer to do that. And so that's what we do. That's what we try to do. These are some pictures of different environments, where we're in. So tanks, vessels, tunnels, etc. And the use cases are endless. Tunnels, we have talked to, for example, the DEA is an example where there are drug cartel tunnels, which they would love to kind of get into. There are silos and things in the world of maritime that need to be inspected. The far right picture is a cell phone tower. And you probably can't see it, but well, I guess you might be able to. These little pegs here are what somebody actually climbs up on. And they have to inspect those every so often so that the people that are going up there are safe. And so right now they do it very manually, and they take pictures, and it takes like 2 or 3 days to just do one of these towers. And they've estimated that if they can use an autonomous drone, that it would cut that to about a half a day, maybe a day at most. And as you're just kind of flying up, and it's doing it automatically, taking a picture, flying up, taking a picture, and then comparing it to the data set that they have, and so they can know real time if something's off a little bit because they have figured out what that criteria is in their world. So at the end of the day, it's all about the intelligence and the insight that you gather. That's why you guys are sitting here today. It's all about that data. It's all about what am I getting out of this machine, And in our world, there are places where people can't go or don't want to go, and that's where we focus on, is how do you take that autonomous machine and go into these places that might be dark, dirty, dull, dangerous, whatever you want to call it. A couple other use cases I'll just share with you that we're working on, but they're different, as in any scientific endeavor or not, they're all in different stages. This one's in a very early stage. It's a larger VTOL, fully patented delivery logistics type of vehicle that we've gotten pretty far with, but we kind of had to focus on what we were focused on. So it's still sitting there, and we'll get to it. And then this is something we actually are working on with the University of Maryland as a partner-internship agreement funded by National Science Foundation to actually do mine sweeping. And mines, undetonated mines, are a problem all around the world. The researcher that we're working with this on, her husband is a Marine, and she told me that her friends, colleagues, husband's friends sometimes didn't come home, or they came home maimed or losing a limb, and that was something that she was motivated to try to solve. And so she's got the machinery or the sensors for this, and we're providing the platform. And so it's a couple-year project where we're going to start. Later this year, we'll probably be doing the flight testing with it. So we're doing a lot on AI autonomy, and I'm going to leave you with a video, and then we'll get to Q&A, actually, if we have some time for that, that kind of gets to where we're going in terms of, and not just us, but the industry, where it's full autonomy. And so I'm going to show you a very quick video of a fully autonomous inspection of a famous landmark, and let's see if it works. And it does. Cool. I don't know if we have the music, but that's okay. It has cool music, but oh, there we go. And we're not that far away from this. Not quite there yet, though, but. So this is the Christ the Redeemer in Brazil, Rio. To have this path that you know it, and it's going to just go do it. And by the way, this thing does get inspected for real. Not with a drone right now, though. They actually put scaffolding up, so imagine how much time that takes. What you're seeing there is the actual vehicle thrust vectoring, so that's something we do. So as you can tell, I'm kind of a geek around this stuff. I'm very passionate. By the way, who's seen Top Gun? It was awesome. Yes, okay, good. I'm going to see it again, actually, on IMAX. But anyways, I'd love to entertain any Q&A if you have any, or comments, or what have you. Make your way, or just yell if you want to. That's fine. No questions? Oh, here comes somebody. All right.
I could yell. You'd be the only one who hears me.
Sure.
It's some pretty cool stuff. In NASA, they've been launching autonomous satellites for decades, right? And it's a very simple environment, right? You're up in space, there's no gravity vectors, no nothing. But things go wrong all the time, and these things go into safe mode, right? The computer just shuts down and says, I don't know what's going on. I'm going to wait until someone contacts me and tells me what to do.
Yep.
For an autonomous drone, you're going to have the same thing, right? It's going to get confused, but it's harder for a drone to shut down when it's 100 feet in the air. So what is your failure mode? How do you deal with things like that?
That's a great question. So on that icon slide I showed you, there were a few buttons, and some of them were So for example, in the world that we are playing in, which is this sort of indoor autonomous world, and you're going around walls and around corners and into other rooms and things, yeah, you could lose comms. So we have designed fail-safe, so if you lose communications, one of a few things can happen. One, just land. Like it'll just auto land. Two, could be return home. Just take your path back home. Three, finish the mission and land. Or and so there's a whole number of these things. Same with battery life. Okay, you're going to get to a certain point. Batteries are a problem still in the industry. We don't have the energy density we want yet, and so you're still going to have, in many cases, where you're working on a mission and you're going to get to a point where the battery runs out, or gets to a point where, in our case, the fail-safe is you get to a certain percentage of battery life. Either come home the shortest path you can figure out. This is now like sort of the autonomy or the AI neural network trying to figure out its path, or just go ahead and land again, and we'll come get you. So there's a whole number of things you could do there depending on the requirements of the user. And I would say in some mission critical situations where you're, like in the DoD world, for example, you may not care if the machine comes back. You may be like, just accomplish the mission, right? And we're actually, we're in talks with various entities that are working with Ukraine, and that's some of what's okay, right, in what we're seeing. By the way, the Ukraine situation is kind of a glimpse into the future, a little bit of what I would call drone warfare, or just war, so. But yeah, does that answer your question?
Yeah, it does.
Thank you.
So I don't have a Tesla, but my brother-in-law does, and if I remember correctly, I don't think that it has LiDAR on it.
No, it doesn't. It's all vision-based.
Right. So I remember that being kind of a thing of all the, the original Google self-driving cars all had LiDAR, and they seem to be moving more towards just video. Mm-hmm. And you mentioned that, your drones in particular mm-hmm. use LiDAR. Mm-hmm. So I was kind of wondering about the rationale behind that.
Yeah, so I think it depends on the use case, right? So in our world, again, if I go to why we're here about data, insight, and getting that out of whatever machine you're using. It doesn't matter what machine you're using, but you want the data. The LiDAR does a lot for you. It can help you with the collision avoidance. It can give you mapping as well. So you're getting a lot out of it. Now, in in my Tesla, for example, you have a much bigger vehicle too, so you can put a ton of cameras on it as well. Where in a small little thing like about this big, we have actually 3 or 4 cameras on it, but at some point you run out of room for that, and energy, it takes energy and battery power and all that sort of thing. So the LiDAR for us works really well because it again, depends on the use case. Now there are other drones on the market. I'll give you an example. A Skydio, for example, they are completely vision-based. Well, here's one of the reasons why you might use LiDAR. When you have varying light conditions or it gets dark, the vision stuff doesn't work as well. LiDAR, I can fly this drone in the pitch black, actually, and with the sensor fusion we have on it, and it'll still work. It'll still operate. It'll still avoid hitting things. So there's that as well. That's one of the reasons why you would go with a LiDAR for varying light conditions, is just easier as well.
Very cool. Second question. Are you seeing a Moore's Law type curve in the amount of computation that you can fit to do this sort of edge calculation, kind of real time, in the drone itself? That's
a great question. It's getting there. So, for example, NVIDIA is a big maker of these boards that are you could do a lot on, and there are limitations. Like we've actually exceeded the limitations of these boards with the algorithms that we're working on, but they are happening very fast where they're upgrading. Like we're working with one of the most advanced NVIDIA boards, for example, right now, and they just came out with another one. So you're going to get the dev kit, you're going to experiment with it, et cetera. But yeah, it is happening fairly fast. I haven't seen the size get down to where we'd love to see it yet, but it is getting smaller.
Gotcha. Thank you.
Mm-hmm. Any other questions, comments? All right. Thank you.